Hello everyone, welcome to another video. And today we have two models. We have sample project file with the name old model, and I did copy that file in order to have simulation for a new model. So later we will change some elements here and run our script to see result of that script. And the goal for this script is actually to see what changes do we have between two models. So let's make some change in this first model. So for example, we can move this pipe somewhere here. We can delete, for example, this element, and we will also create some new elements. And that is okay, but first we need to have information regarding all elements from the old model. So I will jump to that old model and run my script for the old model. And the script is completed. And this script and the script for the new model will always have some warnings, because for example, when you want to receive the location from all elements in the active view, Dynamo will also find some elements which does not have location, but I will show you that later inside the script. So now we have all the information that we need for the old model. Now we will go to the new model and run the script for the new model. And as we expected, we have now information for the new elements. New elements will be in the green color. Changed elements will be in the yellow color. All other elements which are not either new or changed will be basically transparent. But the important thing which you will need to know for this script is that if you delete some elements inside your new model, the script cannot show you that element in the red color because it's deleted, so you don't have that element inside your model anymore. And in order to show all deleted elements, we will need to go back to the old model. What is the product from this second script? So basically all new elements which we didn't have in the old model are green, and that is okay. But when you click on the changed element, and when you click on this element, you will have a new project parameter which will basically tell you what is the reason for the change. So we did change this pipe, and our parameter reports that location changed. And now because we moved this pipe, we also increased the length of this pipe, and also the center of location is changed. So it will report that the change is made in the parameter regarding the length and location. And also here, because we moved this pipe, this length over here increased, and also we did shift that center of location, and the same thing here, but here we did decrease the length. So it's not just that you will have a color for the changed element, you will also have a description what did change. So if we now run our third script, now you can see the result, and again deleted elements will be in the red color. All other elements should have 50% transparency, and of course you can run all those scripts from any active view. So for example, if we go to 3D view, if we want to run our second script again, let's play a little bit more with the elements. So let's delete this portion of the duct. Let's change the size of this duct over here. What else we can do? We can change the height, for example, for these two terminals. And let's also change the type for this mechanical equipment. And okay, now we will run our second script. And you will notice that when you change, for example, main duct, that as a consequence will change the length of all branch ducts. So a lot of elements will be yellow now. Okay, let's see what's changed. So because we changed the size of of the duct we have new element, new reduction element, and probably when we run that script which will highlight deleted elements in the model number 1, in the old model, we will have this old reduction highlighted for deleted element. We also have new tab element because they now have different size. And as we say, the length and location for these branches is now changed because we did reduce the width of this main duct and the length basically increased, and the center of location for each element is also shifted. For these two terminals we did say that we want to change the height. So again, the Z component of location is changed and the height is changed. And also for this mechanical equipment we did say that we want to change the type. Again, Z component is changed. Okay, and let's now run our third script from the old model. And again, let's jump to 3D view. And I will run my script again. So as you can see, that entire portion of the duct is deleted in our new script. That is okay. But also, as I told you, at the moment when we change the size of this duct, all those reduction and joining elements are now have a different dimension. Script for the new model reported those elements as new elements, and this script for deleted elements reported that basically those previous elements with different sizes are deleted. And that's it. Now we will jump to Dynamo to see each of these scripts. And this is a script for the old model. So first of all, we want to have all elements in the active view. We'll took all elements and then basically we'll separate those elements in order to read 7 different parameters. And now I will run the script so we can see the outputs from the nodes. So first of all, we need to read all elements that we have in the active view. From this point, we will basically separate that input to 7 different sides in order to read 7 different parameters. And the goal for this entire script is to read all those parameters and to send all those data to the Excel file. So let's go from the start. We did read all the elements. And now, first of all, we need to read all unique IDs that we have for our elements inside the model. Then we will ask the Dynamo to provide us information regarding the location. And for all those string type of parameters, basically we will check if the values inside this node are null. If we find the elements which have the value null, we will basically replace those values with a no value string. So the output from this node will be, if we find the location for the element, we will have some point or some line. But if we don't have a value for location, we will say no value, and we will export those data to Excel. That is for unique ID and location. Then I want to know the height of each element which I have in the model. So I will convert elements to solid, and I will ask for the center point of that solid. And from this point, I'm only interested for the Z coordinate. I will round those numbers. I will replace now again with a no value, and my output regarding the height will be value if I have a value, or I will say no value if I find the null value. Okay, and now we have basically a very similar story for the size, type, length, and system type. So basically we want to have information regarding all those parameters, and later when we have all this data from the old model, we will read the same parameters for the new model, and then we will compare that entire data, and that as a product will deliver that information to the user, which parameter is changed between old and the new model. So when we have all values for all parameters, I will assemble all of that into the one list, and basically from this point I will export all of that to the Excel file. So the sheet name will be my name, it should start from A1, the file path is that, and that's it. So output from this entire script should be Excel file. That is the script number 1. Script number 2, and I will also run this script so we can read the output from the nodes. Now, just looking from the distance, I will try to explain you what is my idea behind the script. So first of all, I will create new project parameter, and I will take a look if that project parameter already exists in the script. In order to avoid situation every time you run the script you will create new project parameter. So after you run the script 10 times you will have 10 different project parameters. So we want to avoid that, and we will see if we already have in our model project parameter, we will avoid creation of the new project parameter. We will just change the value for the existing project parameter. Then this upper part over here will read all those data from the Excel from the old model. This part over here will read all the existing elements and their parameters which we have in the new model. This part over here will basically compare old and new data, and for all new elements it will color them in the green color. This part over here will basically again compare all the new data, and as a result we will know which elements are deleted, and again we will export those elements to Excel so we can read that data for our third script. And over here we need to compare all the new data, and for all change parameters we will need to color them in the yellow color. And for all elements which are the same between the old and the new model, so those elements are not new, not deleted, not changed, and for those elements we will just change their transparency. And okay, let's start with the project parameter. So okay, I will create the parameter which is called what is the change. Both types are text, and here I will basically ask the Revit if the same parameter exists. If that parameter exists, I will basically create some dummy logical node in order to avoid creation of the new parameter. If that parameter does not exist, I will proceed with creation of this new parameter. And let's go with the old. So we need to read all the data which we have in our Excel. Basically, first index is unique ID, second index is location, height, system type, size, and finally length. So from this point we will have only those elements in our nodes. And now, as I told you, we will compare all the elements which we have in the new model and which we have in the old model. And basically this filter over here will separate the elements which we have in the old and in the new model. When we comparing the elements in the old and the new model, and we find some elements in the old model and we don't have those elements in the new, that means that basically those elements are deleted, and we will export them in order to use them for our third script. And basically this filter over here we will use for all data regarding the parameters that we just read. So we want to proceed only with the elements which are not deleted. Okay, if we jump for a moment to reading the current elements and their parameters in the new model. So this part here deals with the new model, with the current model, in which we want to show new elements and change elements. So first of all, if you already run the script and you already color some elements, we want to reset that before we start coloring those elements again. Then we will read all elements which we have in the model, and again we will read all those 7 parameters. So unique ID, height, location, size, family type, length, and system type. And again, if we have a value, we'll proceed with the value. If we don't have a value, we have a null for the value. We want to replace that with a string no value. Same procedure as we already done for the old model. So now when we have the data from the old model and data from the new model, we can compare those data and see what's changed. So here my idea was, okay, I want to join all those strings, and between different values I will use exclamation mark, so I can further in the script separate those values. And my idea was, okay, so I have 141 element which is not either deleted or new element, and I have a 141 values for one parameter, but I have 7 different parameters, and I need to compare all of that with the new model. And now my idea is, if everything stays the same, okay, that element is not changed. If anything from those values over here is changed, then I will know that I have some kind of change, and later I will again separate all of that in order to find that change. Okay, so the same story is here. We did join all those data, and we will go up here. We want to compare those data, so we want to count how many true values we have after we compare the data. So basically every time when I have a 0, that basically means that in those elements I have some kind of change. So I want to find the index for all those elements. Now I will split the data from the old model and the data from the new model, and now only for those, I think 22 elements, 23 elements, I want to see what is the change. So now, for example, if we open the outputs from these two nodes, basically we can tell that height is changed and everything else was the same. So if we go to some, basically the size is changed, and it is possible that this is our main duct. So from the 300 by 300 we did change that duct size to be 200 by 300. Okay, and now it's very easy. From this new model we will be unique ID, so we want to have a list of unique IDs. We want to convert that to this Python script. This Python script is not created by me. I did find this Python script on the Dynamo forum, and in the description of this video you can find a link to this web page. This Python script will take those unique IDs and convert that to the element IDs. So we can say, okay, for those elements you need to change the color to be yellow. And now we know for which elements we need to change the color, but we also need to find the parameter which is the reason for the change. So basically, again, we are comparing all the new data for each element which does have a change. And over here you can see that we have a change of location and the height. So every time we find a false for a value, we want to know the index for those elements. And now we will flat all of that, and I did write over here very simple script. So every time when you find 1, that means that location is changed. Every time you find 2, it's height, and so on and so on. Because I did flat that list, when I complete with the Python, I know I did basically transfer the value of index to description of the change. So again, I need to basically separate all those values, and in case when I have multiple parameters change, I want to join all of that, and that will be the value for our what is the change parameter. And as we told, for all elements which are not either new, deleted, or change, we want to basically have a list of those elements, and we want to set their transparency to be 50%. And that is the entire script number 2. Now let's see the script number 3. So this is the script number 3. I did run the script so we can have values. And first of all, we need to read that Excel file in which we store the deleted unique IDs. And from this point, we'll have a list of all unique IDs which are deleted. We will transfer that to the element IDs, and we can override the appearance of those elements. That is okay. So again, we have the same story for the case when you already run the script. So each time when you run the script, we will reset elements override. So you can see only the output from this node over here. Aside from that, if the elements are not deleted in that new model, we want to change the transparency for all other elements which we have in the model to have transparency of 50%. In that way, we will have better visualization of that data regarding the deleted elements. So over here you can see that all elements which are not deleted have transparency 50%, and it's better for you to see which elements are deleted. And that's it for this video. Thank you for watching. Bye.